Hello. In this video we're going to talk a little bit about sketches. When you first start Inventor you need to create a sketch in order to create any parts from that. So what we're going to do is go to New here. Make sure you open the correct template, which is going to be a millimeter template because we don't want any of those silly inches. And then it'll open up to this workspace here. We need to start a new sketch, and if you haven't already got an object you need to start a sketch using one of the three planes in space, so XY, YZ or XZ. I like XY. Then you can use your tools up here, okay, to create your sketch, and as I go along you'll see what they're used for. Project geometry is something that you do when you want to add features from one sketch or from one object onto a new sketch. This is how we modify our sketch, by moving, trimming, extending, offsetting, stretching, scaling, etc., etc. You can create patterns in a sketch, okay, and then but the main thing I'm going to be focusing on are the constraints, because the constraints is what keeps our sketch fully constrained. Without a fully constrained sketch you don't have a part that is able to be controlled. Alright, so I'm going to start here with the most obvious constraint, which is dimensions. So with dimensions, okay, if I draw a line like that, I can dimension that line like that, and then I can actually say what length I want the line to be. Okay, so the dimensions are dynamic in that you put the dimension that you want into the box and it'll make the line that length. So if I say I want that line to be 20 millimeters, notice I don't have to put in the millimeters because this sketch is all in millimeters. Okay, now my sketch is no longer fully constrained, it's got 2 dimensions needed. Before I put that one on it would have said 3 dimensions needed. Okay, so there's my sketch. If I draw another line and then hit enter, I can choose dimension again, and I can do a couple of things. I can say the dimension between that line and that line is, and once again I can choose how far I want those 2 lines apart. I can say I want this line and that point of the line, so the end of the line and that end of the line, to be a certain distance apart. Alright, I can say that I want this line to be the same length as that line. So if I choose that dimension, when it asks to input the dimension, it'll set it. You can see that it's fixed to 20 because this one's 20. If I change the length of this one by double clicking on it, I can make that, let's say, 25. You'll see that this one changes to 25 as well because this one is reflecting the length of this one. If I put a line on an angle, that adds some more dimensions. Okay, so I can dimension that line by just selecting it and doing a horizontal dimension or doing a vertical dimension. Or if I click on the line a second time, it'll allow me to do an aligned dimension. Alright, so I'm going to stick with an aligned dimension and say that I want that line to be 30 millimeters long. I can also, if I do a dimension between 2 lines that aren't parallel to each other, it'll give me an angle dimension. So I can say I want that dimension to be 45 degrees. Okay, so now I've got a bunch of dimensions on here and it controls the way the sketch works. So if I try and move that line, you can see that all of those dimensions that I put in have to remain the same. Okay, uh, I can move this one up, but I still maintain that 45 degrees between that line, and this line is going to be the same length. Alright, so that's just basic lines and dimensions for lines. Alright, let's get rid of all of that. Dimensions also work for circles and rectangles. Okay, so if I've got a circle, I can say I want the dimension of that circle to be 30 millimeters. Okay, I want, if I draw another circle, just like with my lines, I can say I want the dimension between that circle and that circle to be 30 millimeters horizontally. Okay, notice that they don't have to be in alignment horizontally, and 30 millimeters between that point and that point is still maintained even though it's on an angle. So it's not actually a horizontal dimension, it's just a dimension between those 2 points. Alright, so as long as that is satisfied, then those circles can, that dimension can, I can move the circle around. I can also change the size of this circle because I haven't put a dimension on that yet. Alright, if I do want to put a dimension on it, I can say, I can dimension this one, and I can say I want that to be the same dimension as that. Okay, and then those 2 circles are going to be the same length as each other, same size as each other. Alright, they're both 30. Okay, so you can see how you might use that, that sort of thing, but you can see I can still move it around in space, and that will only stop happening when I fix one of the points to the center point or some other point on the page. Alright, let's get rid of that. Okay, so that's dimensions. Okay, and you know, the same applies to arcs and rectangles and all sorts of things like that. Okay, you put dimensions on because that's the most basic form of constraint. These 3 buttons here just are ways of displaying constraints, okay, or automatically constraining. Okay, so that's automatically constraining, that's showing constraints, and this one here is all about your constraint settings so that it tells you what part of the line it's going to snap to. Alright, let's start having a look at some of these other ones though, because they're really interesting. Okay, so if I've got my 2 lines again, okay, if I use my coincident constraint, which is the first one there, I can say I want that point to be coincident with that one. Okay, so you can see now that the 2 ends of the line have to be lined up with each other. Alright, because they're touching. Okay, similarly, if I undo that, I can say I want the middle of that line to be coincident with the end of that line. Alright, and you can see that it's a bit hard to control because you can't really predict which one it's going to move. Okay, but as long as that constraint is satisfied, I can still move my lines around. Okay, I can also use a coincident constraint to say I want this line to be passing through the center point of my sketch. Okay, so now I've added another constraint there, so now you can see that I can move this line around still. Okay, it doesn't even have to touch the center line, the center point, but that you can see it's remaining in line with that point. Alright, or I can say with my coincident I want the end of that point to be on there, and so now it's a bit more constrained than it was before. Okay, but I've still got a fair bit of freedom, and there's 4 dimensions that I need to make this sketch fully constrained. Okay, so that's that. Other uses of the coincident constraint is if I've got a circle and I've got a line, I can say that I want the line to touch the circle. So I want that point of the line to be contained in that circle. Alright, I can still move it around, but as long as that point is part of the circle, then that's okay. And you can see that if I try and move it off, it actually moves the circle to go with it. Alright, so that's a coincident constraint. I can also say I want the middle of that line to be coincident with the center of the circle. And so now I've got a funny situation where the circle, okay, that constraint has to be satisfied. Alright, so because the middle of the line is going to be in line with the center of the circle, I've effectively created a chord going across the circle, and so that has to be satisfied. Okay, there's other uses for coincident constraints, but you can explore those yourself. Okay, but coincident just means that this point or line is going to be contained in this point or line. Alright. Next one is parallel, and that's fairly self-explanatory. So if I've got a line there and I've got another line there, if I use my parallel constraint, then those two lines are going to be parallel with each other. Okay, if I move one line, it will move the other because they have to remain parallel to each other. Pretty self-explanatory. I'm just going to go up to here. This one is collinear, and with a collinear constraint you can say I want this line to be collinear with this line. So if we do a collinear constraint, I want that one and that one to be in line with each other, and you can see what happens there. Okay, when I want to get out of a command, I'm just hitting my escape button to get out of it. Alright, so you can see here I can do some things to make sure that that rule is going to be obeyed all the time. Alright, what else have we got? This one here is concentric. Okay, so if I've got a circle here and I've got another circle there, alright, if I hit my concentric button, I'll say that one has to be concentric with that, and now those two circles share the same center point. Okay, now those of you that are following along at home will see that I could have done that another way. So if I just undo that concentric constraint, and let's just make one circle a lot bigger than the other so that it shows up better. The other way that I can do it is with a coincident constraint. So if I say that point is going to be in line with that point, then I've effectively done the same thing, which is a concentric constraint. Alright, concentric constraints can also be done with arcs, so not just full circles. So if I draw an arc from there to there, okay, I say I want that arc to be concentric with that circle, then you can see that that arc now fits in there. They share the same center point, but once again I could have just done a coincident constraint with the center point of the arc. Right, let's get rid of that. Next one is perpendicular. Pretty self-explanatory, just like the parallel. Okay, and you can see that because I drew these two lines so that they were perpendicular to each other already, or close to it, it's already assumed that constraint. Okay, and that's one thing you've got to watch out for with constraints. If I draw a line that looks like it's going to be horizontal, it will pick up a horizontal constraint. Alright, so if you don't want that constraint, you can click on it, and you can right click on it, and then you can press delete, and then that way you can change the line so that it's no longer perpendicular. But if I say I want that one to be perpendicular to that, then it will do that. And then if I say I want this one to be perpendicular to that, it'll do it. If I say I want this one to be perpendicular to that, it'll say get out of here. You can't do that. That will over constrain the sketch. Okay, so I just touched on horizontal because that's the next constraint, horizontal. So if I've got a line that looks like this, if I want it to be horizontal, I can click on that and I can make it horizontal. I can also use my horizontal constraint if I've got two lines like this. I can say I want that point of the line and that point of the line to be horizontally in line with each other. Okay, or I can say I want the midpoint of that line to be horizontally constrained to the midpoint of that one. Okay, so there's still some freedom there, but those two lines are going to be in line with each other. Okay, so you can see that by moving that line, alright, I've horizontally constrained them. Okay, if I was to say that these ones are going to be parallel with each other, like that, and then I do a horizontal constraint between that point and that point, what I've effectively said is that they have to remain the same length as each other. Okay, so when I move them, they're going to be in line with each other and they're going to be the same length as each other, which is a bit like one of our constraints that we'll use later on. Vertical constraint is exactly the same principle, except it's vertical instead of horizontal. Now, sometimes with this view cube, you can end up with a sketch like this, and you think, okay, I want this line to be vertical. I hit my vertical constraint and it does that. Okay, and the reason for that is that the sketch is on its side. Alright, so when I flip it back this way, now my vertical is vertical. Alright, that's just one thing to watch out for. If you get your verticals and your horizontals mixed up, you might find that that's the problem. Okay, let's delete all that. We can also use horizontal with circles. Okay, so I can say that I want that point and that point to be horizontally in line with each other. Alright, or I want the middle point of that line to be horizontally lined up with the center of that circle. Okay, and you can see that because those two have got a horizontal constraint, then they all move. Alright, and so when I move this, they're all going to move. Okay, I can still change the angle of this line, but it's going to still obey that rule. Okay, let's get rid of that. Alright, tangent is a cool one. Okay, so tangent constraint, if I've got a line and a circle, I do a tangent between the line and the circle, and then the line has to touch the circle at one point. If I've got two circles and I do a tangent, they have to be in line that way. Okay, and then if I move it around, you can see that that circle is rolling around there, the outside of that. I can also do, obviously, a tangent inside. So if I've got a circle here inside there, I can do a tangent between that circle and that circle, and now that circle is rolling around the inside of that one, and this one's rolling around there. Okay, and you can see all sorts of funky things happening there. Alright, I can say also that I want a tangent between this one and that one. Okay, and you can see there's two choices there. I was expecting it to go the other end, but it went this end instead. Now you can see that it isn't necessarily going to stop on the line, alright, because I can still make this longer, and that rule is still being obeyed, that line is a tangent to that circle and that circle. Okay, if I use my coincident constraint though, and I say I want the end of that line to be contained in that circle, then it'll go like that. Alright, so that's the tangent constraint. Smooth, don't know what that's for, never used it. Yep, don't worry about that one. Symmetrical, alright, so if and in fact I hardly ever use that one either, but if I want symmetry between two lines, okay, it's really just like the mirror constraint. So between there and there, if I do a symmetry constraint between that sketch element, second sketch element is that, select the line of symmetry, and there it is. Okay, so now whatever I do with that one, it has to maintain symmetry between the two of them. Okay, so there it is. If I move this line, it's still going to follow that same pattern. And then the final sketch constraint here is equal. Alright, so if I want that circle to be the same size as this one, okay, I can go that and that is going to be equal. If I want that line and that line to be equal, that's what it'll be. Okay, so they have to be of the same type of line. You can't do equal between a circle and a straight line, okay, because it's saying, well, that's not going to work. You can't do it with a circle and a straight line. Okay, so they have to be the same type. With arcs, if you've got two arcs and you go equal, it will actually say that the radius is the same as each other, not necessarily the length. Okay, so if I say that one is equal with that, alright, you can see that I can still make one longer than the other, okay, but the radius remains the same between the two of them, like that. Okay, and that makes more sense when you put dimensions on there. Okay, so that's the basic constraints, and that's what you should be aiming for. Alright, so when you create a sketch, think about what you want your sketch to look like, what sort of rules do you want in place to make your sketch fully constrained, and then you apply those constraints to make your sketch the way you want. In future videos I'll give you a few tips about how to draw basic shapes, but for this one we're just talking about general sketch constraints and how to make sketches. Once you finish your sketch, you click finish sketch, and then that allows you to do stuff with your sketch. But I haven't really got many enclosed shapes here, so there's not much I can do with this sketch. Alright, thanks for listening.